So today we'll continue with the rest of the hybridization, that is SP3D2 and SP3D3 hybridization. So SP3D2 hybridization will have 1 S, 3 P and 2 D orbitals. So total 6 orbitals it will involve in its hybridization. Now let's take an example, that is sulfur hexafluoride. Sulfur hexafluoride SF6. Now sulfur has an electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p4, and fluorine has an electronic configuration of 1s2, 2s2, 2p5. Now ground state for sulfur will be 3s and 3p. 1 2 1 2 1 1. And the excited state will then become 1 electron from s orbital and 1 electron from p orbital will go into d orbital. Since this is third shell, so d orbital is also included in this. 1 from s and 1 from p. This moves into the excited state. So the hybrid orbital will become SP3D2. 1 2 3 4 5 6. These 6 orbitals will come under SP3D2 hybrid orbital, and these 3 will be left as D unhybridized orbital. Unhybridized. Now come to fluorine. For fluorine molecule, the ground state will be 2s2 and 2p5. So there will be a bond between this fluorine, 2s5, so there will be pairing in this. Let me make this again. Pairing in this, and this will bond with SP3D2. So this bond will be known as SP3D2P bond. P of fluorine and SP3D2 hybridized orbital of your sulfur. So like this, since we have 6 fluorine atoms, each fluorine will bond with SP3D2 hybrid orbitals of sulfur, and this will make a structure which will be called as, this is sulfur, this is fluorine, this is fluorine, this is fluorine, this is fluorine. Now this is your equatorial plane. These 4 fluorine will lie in the equatorial plane and 2 fluorine will lie in your axial plane, as we had discussed earlier. The bond between each of the angle between each of the bonds will be 90 degrees, and this entire structure or geometry is known as your octahedral shape. This has got 4 in equatorial plane and 2 in axial plane. Bond angles are 90 degree. Now let's come to SP3D3 hybridization. SP3D3 hybridization, as we can see, 1s, 3p and 3d orbitals are involved. That means in total 7 atomic orbitals are involved in this hybridization. Let's gain an insight into this through an example, which is IF7. Iodine heptafluoride is an example of SP3D3 hybridization. Now the electronic configuration for iodine, if you see, it's, let's say, krypton, 4d10, 5s2 and 5p5. So these are the orbitals we will be taking into consideration for hybridization. Now let's see for fluorine. For fluorine, the electronic configuration is 1s2, 2s2, 2p5. For iodine, the ground state says 5s2 5p5, 5s and 5p5, 5p5, and the excited state will also involve d orbitals. Now since this is the fifth shell, d orbitals are vacant and available for excitation. So this will be 1 1 1 1, and these three will be excited to 5d. So this is the excited state. Now we'll consider the hybridized state. We'll be taking account these 7 orbitals. So the hybridized state becomes 1 2 3 4 5 6 7 orbitals. This is SP3D3 orbitals, and then there are 2 d unhybridized orbitals. Alright, and then for fluorine, the ground state says 2s and 2p5. So 1 1 1, this is 5. So now there will be bonding between iodine and fluorine to complete its octet. So this will be SP3D3P. This bond will be known as SP3D3P bond, since P of fluorine and SP3D3, since P orbital of fluorine and SP3D3 orbitals of iodine are bonding in this. So similarly, since we have 7 fluorine, each of the hybridized orbital will get one fluorine each. Bond with fluorine, 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 and fluorine. So this will be forming SP3D3 P bonds. And now the structure, if we are coming to structure, it is I is the central metal atom, F, 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 F. These 5 fluorine will be lying in your equatorial plane. These 5 fluorine will be lying in your equatorial plane, and then 2 fluorine along the z axis will form your axial plane. So there is total 7 fluorine attached to the central iodine atom, and this is known as, and this structure is known as your pentagonal bipyramidal structure. Pentagonal bipyramidal structure. So this has got 2 planes, equatorial and axial planes, and it is forming a pentagonal bipyramidal structure. So that's all for today. That's all about hybridization, and if you have any suggestions or comments, you can drop. I also try to upload a tips and tricks video on hybridization so that it's easier for you to recognize hybridization, especially for organic molecules. And that's it for today, and that's all for hybridization. So thanks, and do let me know if you have any suggestions in the comment section. Thank you.